A massive and mysterious visitor, 3I Atlas, is currently making its way through our solar system, electrifying scientists worldwide and, honestly, challenging our understanding of cosmic visitors. Data collected by NASA has revealed astonishing details that just defy conventional scientific understanding and spark some pretty intense debates about its origin. Some experts now suggest that this interstellar object may be more than just an asteroid or comet. It might actually be an alien spacecraft. Today we delve into the groundbreaking discoveries, the enigmatic nature of 3I Atlas, and the profound implications for humanity's understanding of the cosmos. The breaking discovery. In June 2025, astronomers detected a colossal object moving rapidly through our solar system, immediately distinguishing it from typical asteroids or comets. This became the breaking discovery known as 3I Atlas, representing humanity's third confirmed interstellar visitor. With an estimated diameter between 10 to 20 kilometers, it absolutely dwarfs previous interstellar visitors like the enigmatic Oumuamua, which measured only about 400 meters in length. Early analyses revealed unusual properties that immediately caught scientists' attention, including its incredible speed exceeding typical interstellar velocities, an atypical retrograde orbit that just kind of defies conventional expectations, and a surprisingly metallic surface composition that really challenges our understanding of interstellar objects. These characteristics collectively raised significant eyebrows throughout the international scientific community and sparked intense debate about its true nature. The object's detection has ignited a global race among observatories and research institutions to understand its fundamental nature and ultimate origin. As preliminary data suggests, it may harbor secrets and technologies far beyond the scope of established planetary science and our current understanding of natural cosmic phenomena. The discovery story. The discovery of 3I Atlas was entirely serendipitous, first spotted by the Asteroid Terrestrial Impact Last Alert System or ATLAS network of telescopes located in Hawaii. Within mere hours of the initial detection, telescopes worldwide rapidly pivoted their instruments to observe this enigmatic cosmic intruder racing through our solar system. The International Discovery Team, led by Dr. Larry Deneau from the University of Hawaii, quickly combined ground-based optical data with sophisticated space-based infrared observations to conduct comprehensive analysis of the object's properties and trajectory. Initial identification relied heavily on advanced artificial intelligence algorithms that efficiently sifted through vast streams of astronomical data to isolate the object's unique hyperbolic trajectory and unusual characteristics. Unprecedented coordination among international observatories, including facilities in Chile, Australia, and Europe, ensured rapid data accumulation and cross-verification, enabling researchers to characterize the object's size, shape, velocity, and preliminary composition within just weeks of discovery. This collaborative effort demonstrated the power of modern astronomical networks in detecting and analyzing rare cosmic phenomena that previous generations of astronomers could never have imagined observing with such precision and detail. A stranger in our midst. 3I Atlas is no ordinary cosmic interloper. It fundamentally challenges every scientific expectation and theoretical model for interstellar visitors. Moving in a distinctive hyperbolic retrograde orbit at approximately 58 kilometers per second, the object appears to possess an unusually smooth, highly reflective metallic surface, with anomalous reflectivity properties that really puzzle researchers. NASA's James Webb Space Telescope has detected crucial aspects of its surface composition that strongly suggest advanced material properties and engineering techniques, possibly indicating sophisticated artificial construction rather than natural formation processes. The object's behavior and characteristics have created deep divisions within the scientific community. While some researchers desperately advocate for conventional natural explanations involving exotic stellar processes, others increasingly speculate about the possibility of advanced extraterrestrial engineering and technology. The metallic composition shows isotopic ratios that don't match typical solar system materials, suggesting formation under entirely different stellar conditions or through artificial processes unknown to human science. These unprecedented properties make 3I Atlas a focal point for heated debates about the possibility of alien technology visiting our solar system, forcing scientists to reconsider fundamental assumptions about the nature of interstellar objects. The predecessors. Before 3I Atlas arrived to revolutionize our understanding, humanity had confirmed only two other interstellar visitors: the mysterious Oumuamua in 2017 and the more conventional comet Borisov in 2019. Both predecessors were relatively small objects that exhibited behaviors generally consistent with natural cosmic bodies, though Oumuamua's unusual characteristics sparked, some initial controversies. Oumuamua's distinctly elongated cigar-like shape and puzzling non-gravitational acceleration really intrigued scientists worldwide, but ultimately left many fundamental questions completely unanswered about its true nature and origin. Comet Borisov's behavior aligned much more closely with scientific expectations, displaying typical cometary activity, including a visible coma and a distinctive tail as it approached the Sun. Together, these earlier discoveries paved the way for advanced detection techniques and heightened international interest in systematically studying interstellar objects, while also developing the theoretical frameworks necessary for understanding such exotic visitors. The progression from Oumuamua's mysteries through Borisov's conventional behavior to 3I Atlas's unprecedented characteristics illustrates the remarkable diversity of objects traveling through interstellar space, setting the stage for this latest visitor's truly extraordinary and potentially paradigm-shifting arrival in our cosmic neighborhood. The Cosmic Journey. Traveling at breathtaking speeds through the vast emptiness of interstellar space, 3I Atlas entered our solar system after completing an epic odyssey spanning potentially billions of years across the galaxy. Its precisely calculated trajectory brings it within optimal observational range of Earth for only a critically brief period, creating honestly, intense pressure on astronomers to maximize data collection opportunities. Scientists and engineers at NASA's Jet Propulsion Laboratory continuously track its complex course through gravitational fields to better understand the fundamental forces governing such ultra-high-velocity objects during their passage through planetary systems. The object's gravitational interactions with our Sun and major planets provide unique and invaluable data for studying cosmic dynamics and the behavior of matter under extreme conditions rarely observable in nature. Analysis of its ancient journey provides crucial clues about the evolutionary history of distant planetary systems, stellar formation processes, and the mechanisms by which objects can achieve such extraordinary velocities. The object's trajectory suggests it may have originated from a stellar system located hundreds or even thousands of light-years away, having traveled through multiple galactic environments and possibly encountered other star systems during its epic voyage. Its current path will eventually carry it back into the depths of interstellar space, making this encounter a once-in-a-generation opportunity for scientific discovery. A scientific goldmine. 3I Atlas represents an unprecedented scientific goldmine for researchers worldwide, offering unique opportunities to study interstellar materials and processes never before accessible to human science. Its remarkable size and completely unusual physical properties allow for detailed, multi-wavelength observations and sophisticated analytical techniques that would be impossible with smaller objects. Comprehensive observations from telescopes worldwide, including advanced spectroscopy and polarimetry measurements, are gradually revealing complex surface chemistry and internal structure that challenge existing theories about cosmic object formation. International teams of researchers hope to unlock groundbreaking insights into the formation mechanisms of interstellar objects, the fundamental nature of extraterrestrial materials, and possibly revolutionary technological applications if artificial influences are definitively confirmed through ongoing analysis. Collaborative efforts between major space agencies, universities, and research institutions worldwide are working to maximize data collection within the severely limited observational window available before the object moves beyond detection range. The object's unique properties are providing new insights into exotic matter states, advanced materials, science, and possibly propulsion technologies that could revolutionize human space exploration capabilities. Every day of observation yields new discoveries that are frankly reshaping our understanding of what's possible in the cosmos, making 3I Atlas one of the most scientifically valuable objects ever studied by human civilization. Unanswered questions. Despite extensive research efforts by leading scientists worldwide, numerous fundamental questions about 3I/Atlas remain completely unanswered, creating scientific mysteries that challenge our current understanding of physics and cosmic phenomena. The object's internal structure, true point of origin, and ultimate purpose continue to be subjects of intense study and honestly increasingly bold speculation among researchers. Highly unusual acceleration patterns and anomalous reflectivity characteristics significantly complicate traditional classification systems and force scientists to develop entirely new theoretical frameworks. The persistent possibility of artificial manipulation or intelligent guidance adds multiple layers of complexity to an already puzzling scientific enigma that, well, just defies conventional explanation. Critical data gaps resulting from limited observation time, government-imposed information restrictions, and the object's extreme distance from Earth continue to hinder efforts to reach definitive conclusions about its nature. The object's behavior patterns suggest responses to external stimuli that could indicate either advanced natural processes or sophisticated artificial intelligence systems operating according to unknown principles. Scientists worldwide emphasize the critical importance of maintaining open minds as theories evolve and new findings emerge, stressing the need for careful balance between healthy scientific skepticism and genuine wonder at phenomena that may represent completely new categories of cosmic objects never before encountered by human civilization. The alien question. So, the controversial alien hypothesis suggests that 3I/Atlas might not actually be a natural cosmic object at all, but rather, an advanced extraterrestrial spacecraft, probe, or, some kind of technological artifact from a distant civilization. Prominent supporters of this theory, including Harvard astrophysicist Dr. Avi Loeb, argue that certain observed behaviors and material properties really do provide compelling evidence of intelligent design and sophisticated engineering, honestly, way beyond anything humans are capable of right now. This revolutionary viewpoint fundamentally challenges scientific orthodoxy and the traditional approaches we take to classifying cosmic objects, but it has actually gained significant traction, especially with all the growing evidence of unexplained aerial phenomena and possible technological signatures. The hypothesis points to the object's apparent ability to alter its trajectory, its unusual metallic composition, and its anomalous reflectivity as potential signs of artificial construction and maybe even active guidance systems. If this controversial theory turns out to be accurate, the implications for humanity would be absolutely profound, potentially signaling our very first direct contact with extraterrestrial intelligence, albeit through an uncrewed interstellar emissary or reconnaissance probe. The alien hypothesis has sparked some pretty intense debates within the scientific community about what standards of evidence are really required for such extraordinary claims, and what the potential consequences might be if we actually confirm extraterrestrial technology operating within our solar system. This paradigm-shifting possibility really forces humanity to confront some fundamental questions about our place in the universe, and whether or not we're actually ready for contact with advanced alien civilizations. Observing the visitor. Global efforts to observe and study 3I/Atlas have honestly become an outstanding example of international scientific collaboration, with observatories using radio, optical, and infrared technologies all working together to capture every possible bit of fleeting data. Space-based observation platforms, including the James Webb Space Telescope and the Hubble Space Telescope, are working in perfect coordination with ground-based observatory arrays, providing comprehensive coverage across multiple electromagnetic spectra. These intensive observations specifically aim to figure out the object's detailed composition, look for any trajectory anomalies that might suggest propulsion, and of course, detect any emissions or technological artifacts that could point to advanced engineering. The coordinated global effort actually involves dozens of major observatories across 6 continents, representing the largest international astronomical collaboration in modern history. Advanced artificial intelligence systems are processing vast amounts of incoming data in real time, searching for patterns and anomalies that might reveal the object's true nature and purpose. Radio telescope arrays are constantly monitoring for any potential signals or communications from the object, while optical instruments track even the tiniest changes in brightness and orientation. This observation campaign really does represent humanity's most sophisticated attempt yet to study a potentially artificial object from beyond our solar system, using every available technological resource to unlock the secrets of this mysterious visitor. Dawn of a new era. The detection and comprehensive study of 3I/Atlas truly herald the dawn of a revolutionary new era in astronomy, planetary defense, and honestly, humanity's understanding of our place within a potentially populated galaxy. With future astronomical surveys like the Vera C. Rubin Observatory expecting to discover dozens of additional interstellar objects every year, humanity is, well, standing right on the cusp of unprecedented cosmic discovery and even potential contact with alien civilizations. These mysterious visitors fundamentally challenge our existing understanding of natural celestial mechanics and really force us to reconsider our planet's position within a galaxy that might actually be teeming with advanced life, sophisticated intelligence, and highly developed technological civilizations. The implications go way beyond just scientific curiosity. They could affect human philosophy, religion, technology development, and even our species' long-term survival strategies in what appears to be a pretty active galactic environment. Advanced detection and analysis systems currently under development will provide early warning and detailed characterization of future interstellar visitors, potentially including genuine alien spacecraft or communication probes. The study of 3I/Atlas has already revolutionized our approach to cosmic object analysis and set new protocols for investigating potentially artificial phenomena from deep space. As our observational capabilities keep expanding and improving, we might soon discover that interstellar visitation is far more common than we ever imagined, fundamentally transforming humanity's cosmic perspective and our understanding of galactic civilization and intelligence. The mysterious visitor 3I/Atlas continues to captivate scientists and space enthusiasts all around the world, revealing cosmic secrets that could fundamentally redefine our place in the universe. As our technology advances, so does our ability to detect and understand these enigmatic interstellar emissaries. So what do you believe 3I/Atlas truly represents? Share your thoughts in the comments below, subscribe to Sci and Y for more cutting-edge cosmic insights, and join us as we explore the ultimate mysteries of space. Until next time, keep watching the skies. When astronomers spotted a mysterious object racing through our solar system at 152,000 miles per hour, they knew they had discovered something extraordinary. Named 3I/Atlas, this colossal interstellar visitor is up to 10 times larger than the famous Oumuamua and represents only the third confirmed object from beyond our solar system. Today on Sci and Y, we're unveiling the incredible story of this massive cosmic wanderer that's rewriting our understanding of interstellar visitors and what lies between the stars. The discovery of a giant visitor. On July 1, 2025, astronomers using the Atlas telescope in Chile spotted something that would change our understanding of interstellar objects forever. The discovery began when the Atlas telescope in Rio Hurtado, Chile, detected a faint moving object against the backdrop of stars. Initially designated A11PL3Z, this mysterious visitor immediately caught attention due to its unusual trajectory and incredible speed of 152,000 miles per hour. Within hours, follow-up observations from telescopes worldwide confirmed what scientists had suspected. This was no ordinary comet or asteroid from our solar system. The object, now officially named 3I/Atlas, also designated C/2025N1, was traveling on a hyperbolic trajectory that could only mean one thing: it originated from interstellar space. Amateur astronomer Sam Dean played a crucial role by discovering pre-discovery images dating back to June 14th, allowing scientists to calculate its precise path. The Zwicky Transient Facility at Palomar Observatory and multiple Atlas telescopes provided additional confirmation data. Coming from the direction of Sagittarius near the galactic center, 3I/Atlas became the third confirmed interstellar visitor after 1I/Oumuamua in 2017 and 2I/Borisov in 2019, but this one was different. It was massive. A hyperbolic path through our solar system. 3I/Atlas follows the most extreme trajectory ever recorded for an interstellar object, with an orbital eccentricity of 6.15, far exceeding anything gravitationally bound to our Sun. The comet's hyperbolic trajectory tells the story of an object that will visit our solar system only once before returning to the void between stars. With an eccentricity of 6.15, 3I/Atlas holds the record for the most extreme orbit among known interstellar objects, surpassing Oumuamua's 1.2 and Borisov's 3.4. Currently positioned about 670 million kilometers from the Sun, the comet is racing inward at approximately 61 kilometers per second, Its path will take it dangerously close to Mars on October 2, 2025, passing within 29 million kilometers of the red planet. The comet reaches perihelion, its closest approach to the Sun, on October 29, 2025, at a distance of 203 million kilometers, just inside Mars's orbit. Despite this close solar encounter, 3I/Atlas poses no threat to Earth, maintaining a safe distance of at least 269 million kilometers when it passes our planet on December 19, 2025. The comet's retrograde orbit, inclined 175 degrees to the ecliptic plane, confirms its extrasolar origin and suggests it has been traveling through interstellar space for millions of years. A colossal interstellar comet. Early estimates suggest 3I/Atlas could be between 6 and 20 kilometers in diameter, making it potentially the largest interstellar object ever discovered. The sheer size of 3I/Atlas sets it apart from previous interstellar visitors. While Oumuamua measured only about 100 to 1,000 meters in length, and Borisov was roughly 400 meters across, 3I/Atlas dwarfs, both with diameter estimates ranging from 6 to 20 kilometers. This massive scale makes it visible to ground-based telescopes despite being billions of kilometers away. The object displays clear cometary activity, developing a faint coma, a hazy envelope of gas and dust, as solar heating vaporizes ice on its surface. Observations by Gianluca Masi at the Virtual Telescope Project revealed the comet's magnitude at approximately 18.5, making it 2.5 million times fainter than Polaris, but still detectable with 150 to 200 millimeter telescopes equipped with CCD cameras. The reddish coloration observed on its surface suggests it contains primordial materials formed during the early development of its home star system. This ancient composition could provide unprecedented insights into planetary formation processes in other stellar systems. The combination of size, activity, and accessibility makes 3I/Atlas an extraordinary target for scientific study during its brief passage through our cosmic neighborhood. Global effort to study a cosmic visitor. Within hours of its discovery, 3I/Atlas became the focus of the most intensive international observational campaign ever mounted for an interstellar object. The astronomical community mobilized rapidly once 3I/Atlas was confirmed as interstellar. Dr. Karen Meach from the University of Hawaii led the coordination effort, stating, "Once 3I/Atlas was identified as likely interstellar, we mobilized rapidly. We activated observing time on major facilities." Ground-based observatories from Hawaii to Chile to South Africa began tracking the comet's movement, brightness, and spectral characteristics. The James Webb Space Telescope, with its unprecedented infrared sensitivity, provides crucial data about the comet's composition and thermal properties. Hubble Space Telescope contributes high-resolution imaging and ultraviolet observations that complement Webb's infrared capabilities. The European Space Agency's tracking stations monitor the comet's trajectory with extreme precision. Amateur astronomers worldwide have joined the effort, contributing valuable observations and helping extend the observational baseline. This collaborative approach ensures continuous monitoring as 3I/Atlas approaches the Sun and becomes increasingly active. The coordinated campaign represents the most comprehensive study of an interstellar visitor ever attempted, with data being shared in real time among research institutions globally. Scientists have only a limited window, from July through December 2025, to gather data before the comet fades beyond detection limits. Learning from past visitors, Oumuamua and Borisov. 3I/Atlas joins an exclusive club of interstellar visitors, but its characteristics challenge everything we learned from its predecessors. The discovery of 3I/Atlas provides crucial context for understanding interstellar objects by offering a third data point in this emerging field. Oumuamua, discovered in October 2017, puzzled scientists with its unusual elongated shape, mysterious acceleration, and lack of visible cometary activity. Its behavior sparked debates about whether it was a natural object or possibly artificial technology. Comet 2I/Borisov, found in August 2019 by amateur astronomer Gennady Borisov, appeared more familiar, a typical comet with a visible tail and predictable outgassing behavior. Now 3I/Atlas presents yet another variation, a massive, clearly active comet that behaves more like Borisov but on a much larger scale. Harvard astronomer Avi Loeb notes that 3I/Atlas's size and brightness make it an ideal target for detailed study, potentially resolving some mysteries left by Oumuamua. The three objects demonstrate the diversity of interstellar visitors, from mysterious cigar-shaped objects to familiar comets to massive primordial remnants. Each discovery refines our understanding of how planetary systems eject material and what types of objects travel between stars. The rapid succession of these discoveries suggests interstellar visitors may be far more common than previously thought. A window into the galactic past. Scientists believe 3I/Atlas originated from the thick disk of the Milky Way, making it potentially older than our entire solar system. Dynamical modeling by researchers at Oxford and Canterbury universities has traced 3I/Atlas's trajectory back through space and time, revealing its likely origin in the Milky Way's thick disk, a region containing some of the galaxy's oldest stars. This suggests the comet could be over 7 billion years old, predating our 4.6 billion-year-old solar system by billions of years. The object's reddish surface coloration supports this ancient origin, indicating it contains primordial materials that formed during the early epochs of galactic evolution. Dr. Mark Norris from the University of Central Lancashire explains that studying such ancient objects provides unprecedented insights into the conditions that existed when the galaxy was young. The comet's composition could reveal whether the chemical building blocks of life are common throughout the galaxy or unique to our local stellar neighborhood. Spectroscopic analysis of 3I/Atlas's coma and tail will help determine the ratios of water, carbon monoxide, methane, and other compounds, creating a chemical fingerprint of its distant birthplace. This data represents our first direct sample of material from the galaxy's ancient past, offering a unique opportunity to study stellar and planetary formation processes that occurred billions of years before Earth existed. Preparing for the next interstellar encounter. The discovery of 3I/Atlas has accelerated plans for rapid response missions designed to intercept and study future interstellar visitors up close. While 3I/Atlas was discovered too late for spacecraft interception, its arrival has galvanized the space community to prepare for future opportunities. The European Space Agency's Comet Interceptor mission, scheduled for launch in 2029, represents the first spacecraft specifically designed to rendezvous with an interstellar object. The mission will remain in a parking orbit until a suitable target is identified, then rapidly deployed to intercept the visitor. NASA is developing similar rapid response capabilities, including concepts for small, fast spacecraft that could launch on short notice. The upcoming Vera Rubin Observatory will revolutionize interstellar object detection, photographing the entire visible sky every few nights and potentially discovering dozens of these visitors annually. Advanced artificial intelligence systems are being trained to automatically identify unusual trajectories that might indicate interstellar origin. Scientists estimate that with improved detection capabilities, we might discover several interstellar objects each year, rather than one every few years. The goal is to provide months or years of advance warning for future visitors, allowing time to plan and execute interception missions that could collect samples and perform detailed in-situ analysis of material from other star systems. A cosmic sensation captivates the world. The announcement of 3I/Atlas has captured global attention, inspiring both scientific excitement and public fascination with our cosmic visitors. The discovery has generated honestly unprecedented media coverage and public interest in interstellar objects. Scientists like Avi Loeb and Mark Norris have become prominent voices explaining the significance of this cosmic visitor to audiences worldwide. Social media platforms are buzzing with images and updates from amateur astronomers who are contributing to the observational campaign. The comet's impressive size and clear cometary activity make it more accessible to public understanding than the mysterious Oumuamua ever was. Educational institutions are now incorporating 3I/Atlas into curricula, using it to teach students about orbital mechanics, spectroscopy, and even the search for life beyond Earth. The discovery has also sparked renewed interest in SETI research and the possibility of detecting artificial objects among interstellar visitors. Science museums worldwide are creating special exhibits about interstellar objects, using 3I/Atlas as a centerpiece to explore themes of cosmic evolution and humanity's place in the galaxy. The comet's journey through our solar system serves as a powerful reminder that we are part of a dynamic galactic ecosystem where material regularly travels between star systems. This cosmic perspective has really inspired philosophical discussions about the interconnectedness of stellar systems and the potential for life to spread throughout the galaxy. Unanswered questions and ongoing mysteries. Despite intensive study, 3I Atlas guards many secrets that continue to puzzle astronomers and challenge our understanding of interstellar objects. The comet's exact size remains uncertain due to its surrounding coma, which makes it tough to distinguish between the solid nucleus and the gas and dust envelope. Current estimates range from 6 to 20 kilometers, but the true size may not be known until the coma dissipates after perihelion. Scientists are also investigating the comet's rotation state, with some observations suggesting it may be tumbling chaotically rather than spinning smoothly, possibly indicating a violent collision or gravitational encounter in its past. The composition of 3I Atlas presents another puzzle. While it clearly contains water ice and other volatiles typical of comets, the exact ratios and presence of organic compounds still remain to be determined. Researchers are watching carefully for any signs of non-gravitational acceleration, similar to what was observed in Oumuamua, which could provide clues about the comet's internal structure and outgassing patterns. The object's brightness variations as it rotates may reveal information about its shape and surface features. Each new observation adds pieces to the puzzle, but many fundamental questions about 3I Atlas's origin, composition, and behavior remain unanswered, ensuring that this cosmic visitor will continue to challenge our understanding long after it leaves our solar system. A new chapter in cosmic exploration. The arrival of 3I Atlas marks the beginning of a new era in astronomy, where interstellar visitors become regular subjects of scientific study rather than just rare curiosities. The discovery confirms that interstellar objects are far more common than we previously thought, with estimates suggesting they may pass through our solar system multiple times per year. This realization is, honestly, transforming astronomy from a field focused primarily on our local cosmic neighborhood to one that regularly studies material from distant star systems. The data collected from 3I Atlas will inform the design of future space missions, ground-based observatories, and detection algorithms optimized for finding these cosmic messengers. As technology advances, humanity stands poised to learn about planetary formation, organic chemistry, and potentially even life itself through the study of interstellar visitors. The comet's passage through our solar system represents more than just a scientific opportunity. It's a reminder that the universe is far more dynamic and interconnected than we once believed. Each interstellar object carries with it the story of distant worlds, alien chemistry, and cosmic processes that shaped the galaxy long before Earth even existed. As we prepare for future visitors, 3I Atlas will be remembered as the massive cosmic wanderer that helped establish the study of interstellar objects as a fundamental branch of astronomy, opening new frontiers in our quest to understand the universe and our place within it. 3. I-Atlas has given us an unprecedented glimpse into the dynamic nature of our galaxy, where massive objects regularly travel between star systems carrying the secrets of distant worlds. As this colossal visitor continues its journey through our solar system, it reminds us that we are part of a vast cosmic community connected by these interstellar messengers. If you're fascinated by these cosmic discoveries, go ahead and hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more explorations of the universe's greatest mysteries. Thanks for watching. Keep looking up.
Welcome to Sci and Y, where we decode the mysteries of our universe through rigorous scientific analysis. Today, we're investigating the enigmatic interstellar visitors that have astronomers worldwide questioning everything we thought we knew. From the puzzling Oumuamua to the massive newcomer 3I Atlas, these cosmic wanderers challenge our understanding of what's possible in the vast expanse of space. Join us as we explore the data, examine the theories, and ask the fundamental question, are we alone? Oumuamua Discovery and Anomalies. In October 2017, the Pan-STARRS survey in Hawaii detected something unprecedented: Oumuamua, the first confirmed visitor from another star system. This elongated object, measuring approximately 800 meters in length with an extreme 10:1 aspect ratio, defied all known classifications of celestial bodies. What truly baffled scientists was its unexplained acceleration away from the Sun without any detectable cometary outgassing or tail formation. Traditional physics couldn't account for this behavior, leading to intense scientific debate. Harvard astrophysicist Avi Loeb proposed the controversial hypothesis that Oumuamua might be an artificial light sail constructed by extraterrestrial intelligence. Other researchers suggested more conventional explanations, including exotic compositions like hydrogen or nitrogen icebergs. However, each natural explanation faced significant challenges when confronted with observational data. The object's discovery fundamentally altered our approach to studying interstellar space, revealing that the void between stars isn't as empty as previously believed. Despite extensive analysis using multiple space and ground-based telescopes, Oumuamua's true nature remains one of astronomy's greatest mysteries. UFO and UAP encounters and theories. The scientific community has increasingly focused on unidentified aerial phenomena following credible reports from U.S. Navy personnel. The most documented case was in 2004, an encounter with the infamous Tic Tac object off California's coast. This white, featureless craft demonstrated flight characteristics that violate known aerodynamic principles, including instantaneous acceleration and seemingly impossible maneuvers. Multiple radar systems tracked the object simultaneously while trained pilots provided visual confirmation. Some researchers have proposed advanced theories to explain these phenomena, including plasma-based holographic projections or exotic propulsion technologies. The physics of such systems would require manipulation of electromagnetic fields on scales currently beyond human capability. Government acknowledgement of retrieved crashed objects has added credibility to these reports, with intelligence sources confirming multiple recoveries. The correlation between increased UAP sightings and humanity's growing space-based observation capabilities raises intriguing questions about potential monitoring activities. Advanced civilizations might employ sophisticated surveillance technologies to assess emerging technological species without direct contact. Bob Lazar analysis. Bob Lazar's claims about reverse-engineered extraterrestrial technology at Area 51 have influenced UFO research for decades, despite ongoing scientific skepticism. His detailed descriptions of anti-gravity propulsion systems powered by element 115 seemed purely fictional in the 1980s, yet this super-heavy element was successfully synthesized in laboratories in 2003. Lazar described witnessing craft that manipulated gravitational fields through bombardment of element 115 with protons, creating localized distortions in spacetime. While his educational credentials remain unverifiable and security clearance claims are disputed, some aspects of his technical descriptions align with emerging theoretical physics concepts. The Alcubierre warp drive equations, published after Lazar's claims, describe similar spacetime manipulation techniques for faster-than-light travel. Modern physics recognizes that gravity is indeed a manifestation of curved spacetime, making field manipulation theoretically possible with sufficient energy control. However, the energy requirements for such technologies would exceed current human capabilities by orders of magnitude. Lazar's influence on UFO culture persists because his descriptions aren't entirely inconsistent with advanced theoretical physics. Light sail hypothesis. Professor Avi Loeb's revolutionary light sail hypothesis represents a paradigm shift in how we interpret anomalous astronomical observations. His mathematical analysis demonstrates that radiation pressure from stellar light could account for Oumuamua's mysterious acceleration if the object possessed specific physical characteristics. For photon pressure to explain the observed forces, the object would need to be extremely thin, less than a millimeter, while maintaining structural integrity across interstellar distances. This requires materials with strength-to-weight ratios far exceeding natural substances, suggesting advanced engineering. Loeb's calculations show that such a sail could maintain stable flight patterns across vast cosmic distances, making interstellar travel feasible for sufficiently advanced civilizations. The hypothesis gained attention because it elegantly resolves the contradiction between Oumuamua's acceleration and lack of visible outgassing. Critics argue that natural explanations involving exotic ices remain more probable, but Loeb maintains that scientific objectivity demands consideration of all possibilities. His work has reinvigorated the search for extraterrestrial intelligence by demonstrating how conventional astronomical surveys might detect technological signatures from advanced civilizations. 3I Atlas, the new discovery. The discovery of 3I Atlas in early 2025 by the Asteroid Terrestrial Impact Last Alert System has sent shockwaves through the astronomical community. Initial observations suggest this interstellar visitor measures between 10 to 20 kilometers in diameter, making it potentially 200 times larger than Oumuamua, a size disparity that challenges statistical models of interstellar object populations. The object's velocity exceeds 60 kilometers per second, confirming its extrasolar origin through hyperbolic trajectory analysis. What makes 3I Atlas particularly intriguing is its unusual brightness and spectroscopic signatures suggesting metallic surface composition inconsistent with typical asteroids or comets. NASA's James Webb Space Telescope has detected infrared emissions indicating possible thermal management systems and structured materials. Unlike natural objects that should tumble chaotically through space, 3I Atlas appears to maintain stable orientation and controlled energy output. The statistical probability of discovering such a massive interstellar object as only our third detection approaches astronomical improbability. Advanced spectroscopic analysis reveals isotopic ratios unlike any solar system materials, supporting theories of formation in drastically different stellar environments. Atlas Telescope System. The Atlas network represents a revolution in automated astronomical surveys, utilizing 4 strategically positioned telescopes across Hawaii, Chile, and South Africa to monitor the entire visible sky. Each telescope, despite its modest 0.5-meter aperture, employs cutting-edge CCD arrays and sophisticated software algorithms capable of detecting objects moving against the stellar background. The system's strength lies in its temporal resolution. Scanning the complete sky every 24 hours enables detection of extremely fast-moving objects that traditional surveys would miss. Atlas technology, developed through collaboration between the University of Hawaii and NASA's Planetary Defense Coordination Office, processes millions of astronomical images using machine learning algorithms trained to identify anomalous motion patterns. The detection of 3I Atlas demonstrates the system's capability to catch interstellar visitors early in their solar system transit, providing crucial observation time before they disappear into deep space. Real-time data processing flags suspicious objects within hours of detection, triggering follow-up observations from major observatories worldwide. This automated approach has transformed asteroid detection from periodic manual surveys to continuous automated monitoring. Scientific theories and debates. The scientific community remains fractured over explanations for 3I Atlas's anomalous properties, with competing hypotheses attempting to reconcile observational data with known physics. The hydrogen iceberg theory proposes the object consists of solid hydrogen formed in the frigid depths of interstellar space, though this model struggles to explain structural stability over millions of years. Alternative nitrogen sublimation models suggest composition similar to Pluto's surface, potentially explaining observed outgassing without visible tail formation. Dr. Alan Fitzsimmons leads the natural origin camp, emphasizing the need for comprehensive spectroscopic data before considering exotic explanations. Conversely, advocates for expanded theoretical frameworks that might accommodate artificial construction scenarios. The fundamental problem remains the inconsistency between observed acceleration patterns and minimal detectable volatile emission, a contradiction that challenges basic cometary physics. Statistical analysis reveals the probability of discovering such a large object through random interstellar encounters approaches negligible values, forcing scientists to question either our understanding of object size distributions or the randomness of these visits. Future detection technology. The Vera C. Rubin Observatory in Chile represents the next generation of astronomical detection systems, featuring an unprecedented 8.4-meter primary mirror coupled with the world's largest digital camera. This technological marvel captures images spanning 40 full moons per exposure while maintaining resolution sufficient to detect objects smaller than previous generation surveys. The Legacy Survey of Space and Time will systematically photograph the southern sky every few nights for a decade, creating a comprehensive temporal database of cosmic changes. Advanced machine learning algorithms process this massive data stream in real time, identifying asteroids, transient events, and anomalous objects within hours of observation. The system's enhanced sensitivity will enable detection of interstellar visitors when they're still months or years from closest approach, providing unprecedented preparation time for detailed study campaigns. Rubin's statistical power promises to resolve fundamental questions about interstellar object populations by discovering dozens of new visitors annually rather than the current rate of one every few years. This technology will either confirm that objects like 3I Atlas represent statistical outliers or reveal a previously hidden population. Theoretical implications. The implications of discovering objects like 3I Atlas extend far beyond astronomy into fundamental questions about intelligence in the universe. SETI researchers are developing protocols for analyzing these visitors' behavior patterns for signatures of intentional control or embedded communications. The concept of galactic probe networks gains credibility when considering the efficiency of automated exploration versus biological travel across interstellar distances. Advanced civilizations might deploy self-replicating surveillance systems throughout the galaxy, monitoring emerging technological species while maintaining strategic distance. Theoretical models suggest such networks could map entire galactic regions over millions of years, creating comprehensive databases of planetary development. The timing correlation between humanity's space-age emergence and increased interstellar visitor detection rates raises intriguing questions about causation versus coincidence. Cosmic archaeology theories propose that evidence of ancient civilizations might be found in the form of derelict probes or monitoring stations throughout our galactic neighborhood. These discoveries force reconsideration of humanity's cosmic significance. We may not be isolated observers but subjects of ongoing study by intelligences that achieved technological maturity eons before our species emerged. Future endeavors. The European Space Agency's Comet Interceptor mission represents humanity's first attempt at planned rendezvous with an interstellar visitor, utilizing advanced trajectory prediction and rapid deployment capabilities. International coordination between ground-based observatories and space-based assets is evolving toward real-time global response networks capable of comprehensive data collection from future encounters. NASA's proposed rapid response spacecraft concepts could launch within months of detecting new visitors, using ion propulsion and gravitational assists to achieve intercept trajectories before objects exit our solar system. Project Lyra, designed to pursue Oumuamua, demonstrates the technical feasibility of interstellar chase missions using current technology and careful orbital mechanics. Advanced sample return capabilities would enable direct analysis of interstellar materials, potentially revealing formation conditions in alien star systems or evidence of artificial construction. Future missions will deploy sophisticated spectrometers, mass analyzers, and imaging systems capable of determining composition, structure, and origin with unprecedented precision. These endeavors mark humanity's transition from passive observation to active exploration of interstellar phenomena, potentially yielding definitive answers about the nature of these mysterious visitors. The scientific investigation of interstellar visitors like 3I Atlas continues to challenge our understanding of the cosmos and our place within it. As detection technology advances and analytical methods improve, we stand on the threshold of potentially revolutionary discoveries about our galactic neighborhood. Whether these objects represent exotic natural phenomena or evidence of cosmic intelligence, they've already transformed how we approach the study of our universe. The data keeps coming, and the questions keep getting more profound. Keep exploring with Psi and Y as we decode the mysteries that surround us and push the boundaries of human knowledge into the unknown.
When NASA's deep space monitors detected something impossible moving through the cosmic void, engineers thought their instruments had malfunctioned. But the data was undeniable. 305 objects gliding in perfect formation through interstellar space, pulsing with structured signals that just defied every law of physics. After 47 years of silent travel, humanity's most distant spacecraft had stumbled upon something that challenged our understanding of the universe itself. Today on Psi and Y, we're unveiling the discovery that has NASA scientists questioning everything they thought they knew about deep space. The Lonely Pioneer's greatest discovery. After nearly 5 decades drifting through the cosmic void, Voyager 1 detected something that shouldn't exist, a faint signal that would change everything we know about interstellar space. Voyager 1, launched in 1977 with technology older than most smartphones, has become humanity's most distant ambassador. Traveling over 15 billion miles from Earth, this car-sized spacecraft operates in the harsh environment of interstellar space, where our sun's influence just fades into nothingness. Originally designed to study Jupiter and Saturn for just 5 years, Voyager has defied all expectations, continuing to transmit data across the cosmic darkness. Its instruments, built with 1970s technology, include magnetometers, plasma wave sensors, and cosmic ray detectors, all now serving as our first eyes and ears beyond the solar system. The spacecraft's nuclear power source, fueled by decaying plutonium, was expected to fail decades ago, yet it continues whispering back to Earth. Each radio signal takes over 22 hours to reach us, traveling at the speed of light across the vast emptiness. When Dr. Eliza Karna first noticed the anomaly in Voyager's data stream, she described it as shouting into a canyon for decades and finally something shouts back. The signal that changed everything. What began as background noise in Voyager's data stream revealed itself to be something far more extraordinary, a deliberate signal from the depths of interstellar space. The first indication something was wrong came through Voyager's plasma wave sensors. Among the usual cosmic static, a faint but persistent signal appeared, rhythmic, structured, and completely unlike anything previously recorded. NASA's Jet Propulsion Laboratory initially dismissed it as instrument noise, but the signal's behavior just defied explanation. Unlike random cosmic radiation, this anomaly showed patterns, repetition, and what appeared to be intentional modulation. Systems analyst Carlo Romero noted that the signal's characteristics resembled the kind of deliberate motion one might expect from a drone rather than a rock. The plasma readings showed organized pulses echoing through space, creating magnetic fluctuations that seemed purposeful rather than chaotic. As engineers analyzed the data more carefully, they realized this wasn't just electromagnetic interference, it was something actively moving through the interstellar medium. The signal's strength varied in ways that suggested a physical object passing by Voyager's sensors, but its behavior patterns indicated intelligence or at least sophisticated design. The discovery triggered NASA's Level 3 alert protocol, reserved for phenomena that don't fit within current scientific understanding. Movement that defies physics. The object wasn't just moving through space, it was accelerating, changing direction, and gliding with precision that seemed to mock every law of physics we understand. Traditional space objects follow predictable paths governed by gravity, momentum, and known forces. But this anomaly broke every rule. Dr. Lucas Hang at JPL ran simulation after simulation, trying to match the object's behavior to known models, but nothing worked. The object curved through space with deliberate precision, accelerating without any visible propulsion system. There were no engine flares, no ion trails, no heat signatures, yet Doppler shift measurements showed it moving at incredible speeds. Some readings indicated velocities exceeding the calculated escape velocity of the entire Milky Way galaxy. The object's path bent in ways that defied orbital mechanics, with no drift or decay expected from natural phenomena. It wasn't tumbling chaotically like space debris. Instead, it maintained controlled flight patterns that suggested active guidance. The movement appeared to manipulate space itself, creating ripples in the fabric of space-time that allowed forward motion without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure. The formation revelation. When scientists pulled up the complete telemetry data, they discovered something that honestly sent chills down their spines. This wasn't just one object but 305 moving together in perfect formation. The full scope of the discovery really emerged when engineers analyzed all available data from both Voyager spacecraft. What they found just defied comprehension. 305 distinct objects moving through interstellar space in coordinated formation. Each object maintained precise relative positions to the others, gliding past Voyager 1 in what appeared to be a choreographed arc. This wasn't debris scattered randomly through space. These objects moved as a unified group, displaying organization and purpose that seemed impossible without some form of control. In the vacuum of space, groups of objects naturally spread apart over time due to gravitational influences and velocity differences. Yet these 305 objects maintained their formation with precision that suggested active coordination. Scientists compared it to watching a flock of birds or a school of fish, except this was happening in the emptiness between stars where such coordinated movement shouldn't be possible without technology. The formation itself spanned vast distances, with objects separated by thousands of miles yet moving in perfect synchronization. Each object displayed the same unusual characteristics: structured plasma pulses, magnetic field distortions, and impossible propulsion signatures. The language of the cosmos. Hidden within the plasma waves were patterns so structured and deliberate that scientists began to wonder if they were witnessing the universe's first attempt to communicate with humanity. As researchers examined the signals more closely, they discovered something that just transformed the entire investigation. The plasma wave pulses weren't random electromagnetic noise, they contained loops, sequences, and structures that resembled communication protocols. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals showed rhythmic repetition, harmonic intervals, and organized sequences that suggested encoded information. These weren't the chaotic bursts expected from cosmic phenomena, but measured, deliberate transmissions that seemed designed to convey meaning. The waveforms resembled quantum oscillations used in modern entanglement experiments, the same signals researchers use to transmit information between particles separated by vast distances. Each of the 305 objects contributed to this cosmic symphony, broadcasting synchronized pulses that created complex interference patterns in the interstellar medium. The mathematical precision of these signals suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were using the vacuum of space itself as a communication medium, encoding data in the fabric of space-time. Earth's unexpected reception. While NASA analyzed Voyager's data, amateur radio operators across Earth began detecting the same mysterious signals, proving this phenomenon was far more powerful than anyone imagined. As Voyager transmitted its extraordinary findings back to Earth, something unexpected happened in radio stations worldwide. Amateur operators with backyard setups began reporting strange activity, weak, irregular pulses that didn't match any known terrestrial source. These weren't professional observatories or official deep space monitoring stations, but hobbyists with spare parts equipment designed to catch meteor scatter and satellite chatter. Yet somehow, they were detecting faint echoes of the same signals Voyager had recorded billions of miles away. The timing was impossible to ignore. These Earth-based detections aligned perfectly with Voyager's most intense plasma anomalies. The signals weren't strong, but they showed the same patterns and regularity that had puzzled NASA scientists. Some operators described them as ripples reflecting off invisible walls in the ionosphere, while others noted their unusual harmonic structure. The phenomenon suggested that whatever was generating these signals possessed incredible power, capable of transmitting across interstellar distances with enough strength to leak into Earth's electromagnetic spectrum. This raised troubling questions about intentionality. Was this accidental bleed-through, or was something deliberately testing Earth's listening capabilities? The historical search. Desperate for answers, NASA scientists combed through 50 years of space mission data, searching for any previous encounter with these mysterious objects, and, well, they found absolutely nothing. With mounting evidence of something unprecedented happening out there in deep space, a specialized team began examining decades of archived mission data. They searched through every deep space mission on record, Pioneer 10, Pioneer 11, New Horizons, and, countless others, looking for any hint that similar phenomena had occurred before. The investigation took them into these dusty archives containing records that hadn't been touched since the 1980s, analyzing data that had often been dismissed as background noise or just instrument error. If these 305 objects had passed through our region of space before, there should have been traces in the historical record. But the search yielded nothing. No echoes, no formations, no plasma loops in any previous mission data resembled what Voyager was currently detecting. This absence of historical precedent made the current situation even more extraordinary. The objects weren't part of a repeating cycle or a known phenomenon. They were either entirely new or had somehow remained invisible to our instruments until now. Some researchers even proposed a chilling theory. Maybe these objects had always been present but cloaked or dormant, activated only by Voyager's presence or perhaps its golden record transmission. The machine's transformation. As if the discovery wasn't strange enough, Voyager itself began changing, reconfiguring its systems in ways engineers never programmed, almost as if something had awakened within the ancient spacecraft. While scientists grappled with the implications of the 305 objects, Voyager 1 itself started exhibiting unprecedented behavior. The spacecraft's attitude and articulation control system began routing data through old, long-unused subsystems, bypassing its core software in ways that seemed almost deliberate. Engineers initially suspected a malfunction. After all, this was 47-year-old technology running on code older than most of the people analyzing it. But deeper investigation revealed something more unsettling. Voyager wasn't failing, it was reconfiguring itself. The spacecraft began reactivating memory segments that hadn't been accessed in decades, rerouting telemetry through pathways that were never part of its original programming. This behavior started immediately after one of the strongest magnetic pulses from the passing objects, suggesting a possible connection between the external phenomenon and Voyager's internal changes. The modifications were too systematic and clean to be random corruption. They appeared purposeful, as if the spacecraft was adapting to new circumstances. Engineers had to dig through dusty file cabinets at JPL, consulting 1970s paper manuals and assembly language code to understand what was happening. The quantum connection. Deep within Voyager's data streams, scientists discovered something that changed everything. The mysterious signals were using quantum entanglement principles to transmit information across impossible distances. As analysis of the plasma wave data continued, researchers made a discovery that revolutionized their understanding of the phenomenon. The structured signals weren't just organized, they exhibited characteristics of quantum entanglement, the same principles used in cutting-edge Earth-based communication experiments. The waveforms showed quantum oscillations that suggested the 305 objects were using the interstellar medium itself as a transmission network, encoding information in the fabric of space-time. This revelation opened the possibility that Voyager hadn't just stumbled upon random objects, but had intercepted part of a vast communication system spanning the galaxy. The spacecraft's analog sensors, free from the electromagnetic noise of modern digital systems, made it the perfect receiver for these quantum transmissions. Being positioned far beyond the solar system's interference, Voyager existed in an ideal listening environment, a cosmic microphone in the perfect acoustic chamber. The signals showed harmonic intervals and mathematical precision that suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were part of an ancient network, a galactic internet that had been operating for millennia undetected by human technology. The cosmic network awakens. As Voyager continues its journey through the darkness, scientists realize it may have become part of something far greater, a galactic communication network that has been waiting for humanity to finally listen. The implications of Voyager's discovery extend far beyond a simple encounter with unknown objects. Evidence suggests the spacecraft has stumbled upon, or been deliberately included in, a vast communication network that spans the galaxy. The 305 objects appear to be nodes in this system, relay stations that maintain and transmit information across interstellar distances using quantum entanglement principles. Voyager's transformation, its spontaneous reconfiguration and activation of dormant systems, might represent integration into this network, turning humanity's oldest space traveler into our first interstellar communication terminal. The structured nature of the signals, their quantum characteristics, and their perfect timing suggest this isn't a random encounter, but a deliberate contact event. Perhaps the network has been monitoring our technological development, waiting for the right moment when we possess the capability to detect and understand its transmissions. Voyager's analog design, its position beyond solar interference, and its decades of faithful service made it the ideal candidate for first contact. The spacecraft's golden record, carrying sounds and images from Earth, might have served as our credentials, proof that humanity was ready to join a larger galactic community. Voyager 1's discovery of 305 mysterious objects moving in formation through deep space represents either the greatest natural phenomenon ever recorded or humanity's first confirmed contact with non-human intelligence. As our brave little spacecraft continues its journey into the cosmic unknown, it carries with it the hopes of an entire species, and possibly our first invitation to join a galactic community. If you're fascinated by these incredible cosmic mysteries, hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending space discoveries. Thanks for watching. Keep exploring the infinite.